Example 1. Evaluate the following. We've got 4 questions to do, and they're all in terms of Z, our standard normal, which has a mean of 0 and a standard deviation of 1. Let's look at this first one. Probability that Z is less than 0.51. Now, less than, this is ticking boxes. We can do this. We don't need to show a lot of working for this. So always a good idea with these questions just to do a little sketch of your normal curve. Doesn't need to be in any way as accurate or as neat as this one is. We know we've got a mean of 0 and a standard deviation of 1, and we are less than 0.51. So I'm going to mark 0.51 on my graph, and I'm less than that, so it is all the data less than 0.51. Now, less than 0 would be half the distribution, and that would be 0.5. So if we're less than 0.51, which is clearly a bigger area, I'm expecting a number that's bigger than 0.5 as my probability. This is where I need to use my calculator. So stat mode, distributions normal, and we are using NCD if we are working out a probability. Now, you should already have this set up from the previous video. If not, go back and have a look at that. So our lower limit needs to be negative, really big negative. So negative infinity, we can't quite put that in, but that will do. Our standard deviation needs to be set to 1, and our mean needs to be set to 0. Our upper limit is the only number we should ever need to change. So 0.51 in this case. Scroll down to the bottom, and you have 2 options under execute: calculate, which is rather boring, and draw, which is much better because it actually draws you a graph which doesn't look a million miles away from our graph. The answer is actually just here at the bottom, so 0.69497, which we're going to give to 4 decimal places when we're working out probabilities under the normal, so 6950. So there we go, and that's all we need to do if it's less than. It's a bit more complicated in some of these other questions. So we'll go on to number 2. Now this one is between 2 values, between 0.51 and 0.63. So we're actually trying to find an area that looks something like that, or probability. Now, although your calculator is capable of doing this, the exam board won't accept it if you just write down the answer here. So we need to be a bit cleverer. We always need to show we've worked out a probability less than a value. So less than 0.63 would look like that, but I want between 0.51 and 0.63, not all the way down to negative infinity. So what I'm actually going to do is take off the probability of being less than 0.51. i.e. the difference is the value I'm after. So let's just go back. That's less than 0.63. That's less than 0.51, and so the difference is what I'm after. Now, less than 0.63 we can do as we did before on our graphical calculator. So come out of there and change your upper limit to 0.63. Scroll down. Draw. This time it's telling me the probability is 0.7357. There. Now, I could work this one out again on the calculator, but it is actually just my answer to part 1. So I can just steal my answer from part 1. And here is where it's really useful to have a more basic GCSE style calculator where you can just chuck in the numbers and out comes the answer, 0.0407. Quite a small probability, but then it's quite a narrow strip there, quite a small area, so that fits. Moving on to number 3, probability that Z is less than negative 2.0. There is nothing particularly special about this question. I've just put it in because negatives can sometimes trip people up. So on our diagram, 0 is obviously right in the middle, so negative 2 is somewhere down here, and we are working out probabilities that it is less than negative 2, so I'm expecting quite a small probability. Again, on the graphical calculator, The only number I am changing is this upper value. Everything else should stay the same. So I'm going to put in -2, scroll down to execute, and we are going to draw that. Calc, if you just want to see, all it is the same information, just without the graph. But I quite like the graph because it confirms we've done it correctly. So 0.0228, and that's all I need to put for my answer there. Moving on to number 4, this one is a little bit more special because it is greater than, and just like this one above, we can, or this one in part 2, your calculator could work this out, but the exam board isn't going to accept it unless we actually show more working than that. So on our graph, we are looking at it being above. I'm going to put 0.8 about here, 0 of course being there. So we're looking at being above 0.8. Now I can't work that out directly, but I do know the area under the whole curve must be 1. So if I add the red area, which is less than 0.8, to the blue area, which is above 0.8, I will get 1 as my sum. So I'm going to take advantage of that and say that the probability of it being greater than 0.8, that's the blue area, is 1, the whole thing, take away the red area. And note now I'm working out a probability that's less than, not more than. And the exam board expect to see this, so only do it this way. On the graphical calculator then, back up, change your upper value this time to be 0.8, scroll down to execute and draw, and our probability comes out to be 0.7881. So we need to do 1 minus this. Again, your basic calculator will do it for you, although a little tip, if you're doing 1 minus a decimal number, what you actually need to do is make each digit add up to 9, except the last one, which we need to add up to 10. So this one's going to be 2, 1, 1, 9, and that's our answer.